Consider function f of x equals the cubed root of x minus 7. It says select g of x so that f of g of x equals g of f of x equals x for all values of x. Well, this problem could be very, very long if we do it step by step. If we figure out, does f of g of x for answer 1 come up to be x? Does f of g of x of the second option come up to be x? Because if the answer is yes, then we have to go the other direction as well. But even though this video is going to be somewhat long, what you may remember from some point in your math career is that f of g of x equals g of f of x equals x if we're working with inverse functions. So I want to go back to our previous lesson, and I didn't write it down, but it won't be too hard to do. If we take f of x equals the cubed root of x minus 7, and we start by finding the inverse. So remember, when we find the inverse, we rewrite f of x as y. Then we're going to switch the x and y. Notice that we only switched the x and the y, nothing else. We're going to add 7 to both sides because ultimately what we're trying to do now is we're trying to solve for y. And then what happens is if we undo this cubed root by its inverse operation of cubing, the cubed root and cubing cancel each other out, and we get y equals x plus 7 cubed. This is the inverse function. So then, actually, in order to keep this video short, I don't think I am going to do more, because if I pull this up, which one is it? X plus 7, oh, darn it. X plus 7 cubed, here. But if you were unsure, you could go back and you could figure out, what does f of g of x equal? And then what does g of f of x equal? And they should both equal x. But that's the shortest way to do that problem. Again, to finish this video, f of g of x equals g of f of x equals x is true if the function and the inverse are what you're composing.